All right, we're getting close to building all the skills that we're going to need to work in fractions. We want to talk about two kinds of numbers. It's still related to factors. We're talking about prime numbers and composite numbers. I made reference to prime numbers a few lessons ago. Here are the definitions. A natural number, also called a counting number, 1, 2, 3, 4, 5, and so on, that has exactly two different factors, only itself and one, is called a prime number. If you try to find all the factors of a number and the only thing you come up with is one in that number, it is called a prime. Another statement that you need to remember is that the number 1 is not a prime. That's just a definition. A natural number or a counting number other than 1 that is not prime is called composite. So all of our numbers, counting numbers, 1, 2, 3, and so on, are either prime or composite with the exception of the number 1, and it is neither prime nor composite. So when we look at numbers, if we can find some way to factor them other than 1 in themselves, then they are composite. But if all we can come up with is 1 in the number, then they are prime. So let's look at some numbers and determine whether they are prime or composite. Let's look at this first one. The number we're supposed to test is 39. All right. Well, certainly I know that 1 times 39 is 39. If I can find another pair of numbers, then it will be composite. But if I can't find anything else, then it will be prime. All right. It's an odd number. That means that I don't have to use 2 because even numbers are not factors of odds. How about 3? If I divide 3 into 39, it's going to go 1. 1 times 3 is 3. Bring down the 9. 3 goes into 9 3 times. And 3 times 3 is 9. Remainder of 0. Oh, 3 times 13 is another pair of factors. I can stop and say this is composite. If you can find any factors other than the original 1 times the number, you find the next set, you stop and say, then this is a composite number. It is composed of multiple factors. Okay, let's look at number 2. We're testing the number 23. Well, I know that 1 times 23 gives me 23. Now, it's an odd number, so there's no point in testing any evens. They will not be factors. So I try 3. Well, 3 does not go in there evenly because 3 times 7 will give me 21, and I'm going to have a remainder of 2. So 3 doesn't go in there. 4 is even, so it doesn't go in. 5, no, it doesn't end in a 5 or 0. 6, no, it's even. Remember, even numbers cannot be factors of odd numbers. 7, well, I know my multiplication facts, and 7 goes in there 3 times, which is 21. I have a remainder. 7 doesn't work. 8 is even. 9 isn't going to go in there because 9 times 2 is 18, and I have a remainder of 5. 10 doesn't go in because it doesn't end in the 0. 11, well, 11 is going to go in there 2 times for 22 with 1 left over. 12 can't work. 13, well, I can test it, and it's only going to go in there 1 time, and I'll have 10 left over. Okay, so 14 is not going to work. 15 is, look and see what happens. It's going to go in there 1 time, and I'm going to have a remainder. For all the rest of them, I'm going to have a remainder. So I can physically test every single one of those numbers, but it turns out that 23 is a prime number. The only fact that gives you 23 is 1 times 23. Something else you could have done is just think about your multiplication facts. I can think of ways to get 20. I can think of ways to get 21 or 22 or 24, but I don't have any other multiplication facts in my head to get 23. All right, let's try 43. All right, well, it's odd again, so don't bother to try any evens. They will not be factors. Can you think of blank times blank, any of the multiplication facts you ever studied that come up with 43? Well, I can't. 2 won't go into it. You could try 3. Goes in there 1 time. Subtract, bring down the 3. It's going to go in there 4 times, but there's a remainder. 3 didn't work. 4 is even. It's not going to work. 5 won't work because it doesn't end in a 5 or a 0. 6 is even. It doesn't work. 7, I don't have to even test 7, really, because I know that 7 times 6 is 42, and I'm going to have a remainder. I don't have to test 8. 9 is not going to work. I know that there's not 9 times a number gives me 43. 10 can't work. 11 will go into 44, but it won't go into 43. I can begin to test, but what I'm realizing is that of all my multiplication facts that I ever learned, I never had one that was blank times blank is 43. 43 is a prime. 1. This is the one that is neither prime nor composite. It is neither. Okay. Number 5. Now this is the first one we've tested in a while that is an even number. Now that's helpful. I know that 1 times 18 is a pair of factors. If the number you have to test is even, then 2 is a factor. It goes in there 9 times. So 2 times 9. And I don't have to go any further. There are other factors, but I don't have to worry about it because even numbers are all divisible by 2. That means that there's at least 2 sets of factors, so this is composite. Now, something to notice is the only even prime is 2. Anything else bigger, if it's even, it is a composite number. And here are, let's just talk about and make a list of primes. 2 is a prime number because the only way to get it is 1 times 2. 3 is a prime. 4, I'm going to write the numbers and then we're going to mark them off. The multiplication facts are going to come in handy. Oops. All right, 2 is a prime. 3, the only way to get 3 is 3 times 1. 4, not a prime because not only is it 1 times 4, but 2 goes in there. It's 2 times 2. Is 5 a prime? Yes, there's only one way to get 5, and that's 1 times 5. 6, not a prime. First of all, it's even, and that means that not only 1 times 6, but 2 times 3. And when you get another pair, it's not a prime, and I'm listing primes. 7, the only way to get 7 is 1 times 7. It's a prime. 8, nope, it's an even. It's divisible by 2. Now 9, we've been keeping, we kept 3, we kept 5, we kept 7, but 9, can you think of a way to get 9 other than 1 times 1? Well, yeah, 3 times 3, so it's not prime. It's a composite number. 10 is a composite number because it's even. 11, the only way to get 11 is 1 times 11. All right, so that was a prime. 12, can you think of any pair of numbers that multiply together to give you 12 other than 12 and 1? Well, yes, it's even, so it's 2 and 6, or it's 3 and 4, so that's a prime. 13, nope, that's prime. 14, not prime. 15, it's an odd number, but not only is it 1 times 15 to get 15, but it's 3 times 5, so that's a composite. Composite. 17, there's no fact other than 1 times 17 that gives you 17. 18, it's even, has to be composite. 19, that is a prime. 20, no, it's even, has to be composite. 21, it's odd, but not only is it 1 times 21, but 7 times 3. So that's composite. 22, well, it's even, so forget it. And I guess we could do at least one more. 23, think of your facts. This is where knowing those multiplication facts is helpful, because you can get 21, you can get 24, you can get 22. There's no way to get 23 except 1 times 23. So it is a pretty big process to determine and test numbers as they get bigger and bigger, whether they're prime or composite. People have even written computer programs to do this, but we can test reasonably small numbers to see if they are prime or composite. We're going to use these prime numbers in our next lesson.